Hey everyone, it's me. I just wanted to put in some last minute chapter 7 notes because when I see you probably tomorrow, we're going to have our chapter 7 test. I'm going to do a quick overview of the sections that I've covered, and then I'll do section 7.3. So this video might be a little bit longer than some of the others, but just be sure and look over it, look over your notes and the practice problems that we've done. Okay, so basically in 7.1, the big part was basically knowing the difference between a population and a parameter and understanding what we use for population and what we use for statistics for the sample. Okay, so when we use quantitative variables, we use mu and sigma for the population, but we use S bar, X bar, and S of X for the standard deviation. And then for categorical variables, we use P to represent the population proportion, and we use P hat to represent our sample. Okay, be very careful with that. I'm going to be nitpicky on that because if you guys make a mistake on that, you're going to lose points on the AP exam. So we talked about that. You're going to have a short answer question that's basically very similar to this. It's going to have two parts to it. There's 5 things that you're going to have to name. You're going to have to see which one's a parameter and which one's a statistic. So this is a great example of a short answer problem. Okay. So understand the difference between a population distribution, the distribution of the sample, and a sampling distribution. That's huge because sampling distribution is a lot of samples, shows the statistical values from all the possible samples. So remember, I told you guys to make sure this is a short answer question or a multiple choice, a multiple choice question. So these are very important right here. What I would suggest you do is make sure you understand the difference between these 3 things right here, okay? Understand that a sampling distribution and a distribution of the sample are 2 very different things. Sampling is multiple samples. A sample distribution is just 1 sample, so be very careful, all right? Understand that we want to minimize bias and variability. We can minimize bias by making sure we choose our sample size correctly. The best way to minimize variability is by having a larger sample size. When we use an unbiased, and then understand what an unbiased estimator is. If it's an unbiased estimator, is equal to the true value of the population that's being estimated. So if your p hat, for instance, if your p hat is equal to p, that's an unbiased estimator. If your X bar is equal to the mean of the population, then that is an unbiased estimator as well. So that's what we're talking about, okay? Unbiased, meaning there's no bias whatsoever. Okay, the larger your sample, the better things are. So let's keep going. So then we talked about sample proportions with categorical data. We talked about using the population parameter P. And whenever you do this, you have to, here's your mean and standard deviation. Remember, this is going to be given to you. Okay, I'll make sure I put this up on the board as well. So the only time we can use this, though, is if the standard, if the independence condition is satisfied, which means the sample size is less than 10% of the actual population, okay? And that your mean is actually equal to your proportion, so that's not a formula you need to memorize, you just need to know that. Then, to make sure that it's normal for proportions, you need to use the this NP is greater than or equal to 10, and N times 1 minus P is greater than or equal to 10. All right, so you have to make sure these things are met, and this is going to help you a lot with Chapter 8 as well. Make sure you read through these kinds of, you're going to have to do one calculate the mean and standard deviation with a proportion and the probability. So you're going to have to do that, and then you're going to also have to do that with means. So that's from section 7.3. So it's very important that you guys understand how to do these. You can do these on your calculator, but make sure that you draw your normal curve and you state that the curve is normal with a mean and standard deviation. Now, when we're doing this, guys, remember that you have a new standard deviation that you have to calculate. You can't just use the standard deviation that was given to you. Okay? Remember the formulas that you're using for p hat, and again, those formulas will be given to you, so just be very careful that you're using the correct formula. Okay, so now 7.3, we're talking about sample means. Okay, so the mean and standard deviation of sampling distribution here, this one's a little bit easier formula, but again, same thing, the 10% condition has to be satisfied. So be very careful of that. So make sure you have those in there. So again, an example, suppose the number of movies viewed by students in the last year by high school students has an average of 19.3 with a standard deviation of 15.8. Suppose we take a simple random sample of 100 students and calculate the mean number of movies. So then we have to calculate our new mean, which is just using the same mean of the population that we had. But our standard deviation is equal to the standard deviation divided by the square root of the sample size, which here is 100. So the 10% condition has to be met because there are at least 1,000 high school students in the population that we're sampling from. So suppose that a population is normally distributed with a mean and standard deviation, then the sampling distribution has the normal distribution with a mean and standard deviation, what we have, provided that this 10% condition is met. So here's a good example problem. This is very similar to one that you're going to have on the short answer, okay? The length of human pregnancies from conception to birth varies according to the distribution that is approximately normal with a mean of 266 and a standard deviation. Find the probability that a randomly chosen pregnant woman has a pregnancy that lasts for more than 270 days. So we first have to, if we're using this, we're going to find that we're just taking this sample. So it's a mean and standard deviation of this. So this is the mean for this certain normal population. Now, suppose we took a simple random sample of 6 pregnant women. The mean of the pregnant, then we have to calculate the new mean. The mean is actually equal to the same mean that we had, which is right here. Sorry, guys, I keep moving this. Is 266 days, okay? And then the standard deviation is what we use here, and we know that we're talking about it's less than 10% of the population. This 6 right here is less than 10% of the population, so that's what we can use. Now we want to find the probability that the mean pregnancy for women in the sample exceeds. So then when we're doing in the sample, we're going to take the difference, the new mean, and use the new standard deviation. So that's when you have to be very careful. So if it exceeds, remember, you can still do normal CDF with that, okay? And I think there's some example problems in here too that show you guys how to do that. All right, so make sure you guys know how to do these types of problems. We've done several in our activities, but I know it's been very broken up with our snow days and stuff. So just go back and visit them. Make sure you know how to do these problems. Now, if we take a sample, the height of young women follows a normal distribution. and a standard deviation. Find the probability that a randomly selected young woman is taller than 66.5 inches. So we're using the same thing. Now, so here we're taking the normal distribution from the population, and then here we're taking a simple random sample. So understand the difference between these two questions. We're taking a sample here, okay? Now, when we're talking about sampling distributions, as we keep doing, as the population, if the sample is larger, greater than or equal to 30, then the sampling distribution of the means is close to normal as well. So when we're talking about the sampling distribution, it looks more and more like a normal curve, and so we can use these normal calculations with that, with our sampling distribution. That's if, and this is the central limit theorem, right? Last one we used was the large counts condition. So the large counts condition was in 7.2. Let me talk to you a little bit about that. Large counts condition is the NP is greater than or equal to 10 and N times 1 minus P. This is large counts. Okay, so this is the large counts condition. All right. And then when we get to greater than or equal to 30, when we're talking about the means is when we use the central limit theorem. Okay. So be very careful with these. I know it's confusing, but we're going to keep using it throughout chapter 8. So that's going to help you a little bit, hopefully, repetition. So this is the central limit theorem here. Okay. So moving on. So the central limit theorem says that when the sample size is large, the sampling distribution of the mean is approximately normal. So this would have to be, but remember this large condition is that N has to be greater than or equal to 30. Okay, that's your sample size. N is your sample size. How large the sample size is needed, here we go, depends on the shape of the population. Obviously, we use this to be N is greater than or equal to 30, and it's called the normal condition, using the central limit theorem. So here's what we're talking about. Suppose the mean number of texts during a typical day randomly during high school student follows a right skewed distribution with a mean of 15 and standard deviation of 35. Assuming the students in your school are typical texters, how likely is it that a random sample of 50 students will have sent more than a total of 1,000 texts? So first things first is we have to make sure it meets the condition. So it's greater than or equal to 30. We have a sample of 50. So we can assume it's normal through the central limit theorem. So then we calculate the mean and standard deviation. Remember, we know that we can use this, but because the 10% condition is satisfied, right? And then we go ahead and take the probability. So now what I did was I used normal CDF, where my mean is 15, my standard deviation is this, and I think I put in my sample size of 50, yes. So there I get 15.1562. So there's a 16% chance that a random sample of 50 high school students will send more than 1,000 texts in a day. All right, so remember, the things that you have to remember is that you have to check the conditions. So remember, things that you need to remember is that you need to check your conditions. Oops, sorry guys. Left. You need to make sure you check your conditions, okay? So know the difference between, oh Lord have mercy, hold on. So know the difference, oh, mercy. So you're gonna know the difference. Oh, this is ridiculous. It should be blue. Hold on. You need to know the difference between sample means and sample proportions. So let's go ahead and talk about that a little bit. Technical difficulties. So make sure you know the difference between sample means oh, for heaven's sake, I am having major technical difficulties. Sample means versus sample proportions. Okay. Know that sample means has the central limit theorem and sample proportions has the large counts. And these are both for normality. Okay, so remember this is n is greater than or equal to 30 and large counts is np is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Okay, so they both have the 10% condition. For independence. Okay, so make sure you check that every time, and that helps you use that enables you to use the formula for standard deviation. Okay, so make sure you know the difference between those two. And make sure you practice some of these problems that we've done in the examples, and also look over your notes, the class notes. Remember the exercises, the last page when we did the summary? That's a huge help to you guys. You won't need to memorize the formula since those are given to you on your formula sheet. You just need to know how to calculate the probability. Remember, when you're calculating the probability for these sample means or sample proportions, you're using new amounts for standard deviation. The means stay the same. Standard deviation changes. Because you're using sample means, your standard deviation needs to get smaller. Okay, so hopefully this helps you guys a little bit. Make sure you're ready for this. It's very important. I went through some notes in class, last class, going through the whole quiz and also all the different multiple choice questions that you got. So if you were not in class, I would definitely try to contact somebody in class and get those notes from them. Very, very, very important. This practice test or this quiz was a great practice for you guys, and it's a great way for you guys to see how ready you are for the test. I'll be also putting up notes for chapter 8 as well. And I've already gone through 8.1 and 8.2. So you might want to wait until after we're done with the test for chapter 7 so you don't get confused, but you might want to start taking those notes down. All right. Hopefully this is helpful to you guys. Let me know if there's anything else I can do, if there's any other videos, if you want me to walk you through some more problems, I'm happy to do that. Just send me a note via Edmodo. I've got plenty of time tonight, so just let me know. See you guys later.